Hey Opties! Today we're looking at non-rigid transformations and we're going to do some practice. This will include stretches and shrinks / compressions for vertical and horizontal. Let's take a look at number 1. It says sketch a graph of the following equation and state the transformation. Okay, so I personally like to state the transformation first. It kind of just directs me onto how to do my graph. So let's do that. Our 3 here is going to be what tells us our transformation. So the number and the location of it on the function tells us what sort of transformation it is. So this is going to be the same thing as if we had f of x equals x in the square root. And then we could say this is the same thing as f of x with a 3 out front. And then we have the 3 out front for our square root of x. So this is a good notation for how we talked about this in our notes. So that's why I wanted to show it to you this way. So it's on the outside, it's multiplied by f of x, which is like our y. So it's going to be affecting our y. It's going to be something vertical. Now 3 is our c. And c is greater than 1. So this is going to be a vertical stretch. That means all of our y values will get multiplied by 3. Okay, so we can first of all say vertical stretch. And we have to say by what factor. Remember, factor just means it's multiplying, right? If a number has factors, that means those are the numbers that you can multiply together to get to that number. So that factor word means multiply. So we're going to say vertical stretch by a factor of 3. So we've stated the transformation here. Now let's graph it. So I would probably look at a regular square root of x and then apply the times 3 to all of my y values. So let's do that. The square root of 0 is 0. Square root of 1 is 1. So here's some points we've got going for square root function. The square root of 4 is 2. And we've got really no other perfect squares here on a graph, but these are enough points to graph it, so we'll be good. So let's write out our points. We've got 0, 0, and we're gonna figure out the new point for that. And notice that our x's aren't going to change. It's only affecting our y. So we can go ahead and fill in our new x is going to be the same x as what we started with. Then we have 1, 1, where 1 is going to remain our x value. And then we have 4, 2, and 4 will remain. So now we just have to multiply all our y values by 3, and then we'll know our new points. 0 times 3 is 0, so that actually stays the same. So I'll make it really big to know it's part of our transform function. 1 times 3 is 3. So this 1, 1 becomes 1, 3. See how we're getting taller? We're stretching it vertically. We're getting taller. And 2 times 3 would be a 6. So we're now at 4, 6. 1, 2, 3, 4, 5, 6. So here is our new square root function. And it doesn't have a function notation, that's just going to be y. Let's just write out the whole entire equation just for good notation. That's that graph. So we're done with number 1. Let's take a look at number 2. Sketch a graph of the following equation and state the transformation. And our equation is y equals the quantity of 2x squared. Now at first look you would think, well, there's a 2 times your x, so it's going to be some sort of horizontal stretch or shrink. And since 2 is greater than 1, it's going to be a horizontal shrink / compression. But you really need to make this equation be in simplest form. Notice that we can simplify this more by squaring 2x. So 2x squared is the same thing as 2x times 2x. Which will be 4x squared. So now our equation is y equals 4x squared. We want to make sure it's as simple as it can get before we start thinking about transformations. Now we can see there's a 4 on the outside. It's not in the parentheses with x. So now we know it's some sort of vertical stretch or shrink. And since c is 4 and c is greater than 1, it's going to be a vertical stretch. So vertical stretch by a factor of 4. So let's plot some points of our parent function quadratic. So we're going to look at those, and then we're going to convert those points to have a vertical stretch by factor 4 by multiplying all of our y values by 4. So the 0 squared is 0, so 0, 0 is one of our points. 2 squared is 4, and negative 2 squared is 4. If you wanted, you could do 3, 9, and negative 3, 9, but these 3 might be enough, but we'll have those just to look at. Let's just take a look at 3 of our points. So we'll do 0, 0, 3, 9, and how about let's do the negative 2, 4. So they're going to change, but only the y values will change because it's just vertical. So we still have 0 for that x value. We still have 3 for this x value and negative 2 for this x value. So let's just multiply all these y values by 4. So 0 times 4 is 0. It's a nice thing about the origin. It usually stays the same, right? If for a stretch or a compression, it will, because multiplying by anything, if you're multiplying by 0, will stay the same. Stay as 0. So 9 times 4 is 36. And 4 times 4 is 16. So let's graph these. We're going to be off the graph for this one, but that's okay. So our 3 goes to like way up here somewhere, 36. And then our negative 2 goes to 16, which is not too far because that's a 10, 11, 12, 13, 14, 15, 16. So this 36 is probably a little bit higher. But what is interesting, or what we really care about seeing, is how much skinnier your new function is, your transform function, is from the parent function. You can see here's where the y equals x squared would be, and it's gotten skinnier because remember, stretching vertically, you're getting taller, you're going to get skinnier. Let's take a look at number 3. Sketch a graph of the following equation and state the transformation. It's going to be a shrink or compression because it's under that for our practice. So let's start by stating the transformation. It's a 1/4 not in the grouping symbol for x. So it's going to be vertical, and since c is 1/4 and c is between 0 and 1, that's going to be a shrink. So vertical shrink by a factor of 1/4. So let's graph some points for just the regular x cubed. 0 cubed is 0, 1 cubed is 1, negative 1 cubed is negative 1, 2 cubed is 8, so 1, 2, 3, 4, 5, 6, 7, 8. And negative 2 cubed is negative 8. So here are some points for our parent function of a cubic. Now let's remember that if it's vertical, it's going to be affecting our y's. So let's start with, say, 0.00, and then our x will stay the same. We'll find our new y. We'll do our 2, 8, and negative 2, negative 8. Since we're going to shrink, it will be much easier to plot these points than to plot like the 1, negative 1, or the 1, 1, the 1, 1, and the negative 1, negative 1, because those will get so small that it'd be hard to see. So negative 2, negative 8, and again our x's will stay the same. So let's find our new y's. We're going to multiply each first y, or current y, by 1/4 to get our new y. So 0 times 1/4 is 0. 8 times 1/4 is the same thing as 8 divided by 4, which is 2. And negative 8 divided by 4, aka also known as negative 8 times 1/4 is going to be a negative 2. So we've got 0, 0 stays the same. And now 2 is on 2. And then negative 2, negative 2. And we know the general shape of a cubic is like this. And we also know that a vertical shrink or compression, it's squishing a graph vertically, right? So it's going to get a little bit wider, a little bit fatter. Let's take a look at number 4. It says sketch a graph of the following equation and state the transformation. So y equals the cube root of 1/8 x. Before we state the transformation, we need to make sure this is in simplest form. We know that the cube root of 8 is 2, and the cube root of 1 is 1. So we could rewrite this as the cube root of 1/8 times the cube root of x, and the cube root of 1/8 is 1/2. Because what you've done is you've taken this and done the cube root of 1 divided by the cube root of 8. So it's 1/2 times the cube root of x. So here's our simplest form. And notice now we have a number on the outside. So it's not horizontal like it may have looked, but it's actually vertical. And it's between 0 and 1, 1/2 is, so it's going to be a shrink slash compression. And that's by a factor of 1/2. Let's plot some points of our parent function of a cubic. So the cube root of 0 is 0, so we have the origin as one of our points. We know the cube root of 8 is 2. The cube root of negative 8 is negative 2. So here are some points of our parent function. Now let's go about writing out these points. So 0, 0, 8, 2, and negative 8, negative 2. Now it's vertical, so it's only going to affect our y's, so our x values stay the same. So let's find out our new y's. We are going to multiply each of these by 1/2. 0 times 1/2 is 0. 2 times 1/2 is 1, since it's the same thing as dividing by 2, right? 2 divided by 2 is 1. And negative 2 times 1/2 is negative 1. So here are our new points, and let's plot them. 0, 0 stays the same. Now we have 8, 1 instead of 2. It's gone half the way down from our y. It was at 2, now it's at 1. You can tell it pretty easily by looking at the graph as well. And then negative 8, negative 1. So here's our new transformed graph. Something like this. It's not perfect, but this is a little bit more straight here. Let's redraw it. Here we go. So if we think about a vertical shrink or compression, it's getting not as tall, right? It's getting shorter. If it's a really horizontally oriented function, like this cubed root of x, it's going to get shorter. If you're thinking about it being something that's kind of like outward, like this, then it might look like it's getting fatter. So it kind of just depends on how the function looks to the way you think about it. But notice it is looking like it's shorter than our original points of our parent function, which is good because that's what it should be. All right, that's it for non-rigid transformations practice. See y'all next time.